Good morning, everyone. Welcome to Indicio Identity Community Meetup for June. Thank you for joining. We are very excited today. Our theme is about bootstrapping trust, leveraging DIDComm to apply trust to existing technologies. We have amazing speakers from HearRo, Big Cooper CEO, and CESPAC CTO. And our moderator is Sam Curren, Chief Architect, Deputy CTO of Indicio. So without further ado, Sam, please take away.
I totally will. Can I screen share mine?
Mm-hmm.
All right. So I apologize for the not beautifulness of my slides. My plan before the last couple weeks got away from me was to employ people with better graphical skills. But hopefully I will be clear in my explanations. What we're going to do today is start out with and talking about some concepts and some examples. The cool part about what we're talking about is that HearRo, that we have as guest today, has already done some of the stuff that we're talking about. And so we will finish up with a conversation about what they're doing, what it looks like, and why that's useful. And so I appreciate them being here and being willing to be involved today. I want to talk about DIDComm as a control channel for digital identity. I want to be clear that the stuff that I'm talking about today is not the announcement of some new technology, but rather a re-understanding or a reimagining of how DIDComm can apply in ways that you may not have seen before. And so this isn't some brand new announcement of something that you've never seen before, but I encourage you to try and understand the concepts that we're describing and how it might be applied in a powerful way in your circumstances that likely already exist. So let me get into it just a little bit here. So this is my very technical diagram of the way that early cell towers worked. Cell towers have early on, they do lots of fancy stuff today, but early on they had dedicated voice channels. So I forget the exact number, it was somewhere in the 50 range, maybe 56 voice channels that a cell tower could handle because of the number of frequencies that were involved. And when you made a call, my dad had the first cell phone he ever had was basically a briefcase, with a handset on it that then would mount in the back of his car. And then he had, the wiring for a little handset up front. I don't know if any of you had cell phones like that, but that was my dad's first cell phone. And it was analog, which means that you didn't just drop the call, but he would just fuzz into nothingness and then sometimes come back and sometimes not because of the analog technology used. And so cell towers work by communicating with the devices, the handsets that were there, and assigning them a voice channel to use on the tower. So when you started a call or you moved from one cell to another cell, and back at the cell transfers were horrendously unreliable in the analog days. They're much better now, but you would communicate with the tower, or rather the cell phone would communicate with the tower to coordinate which of those voice channels are being used. Because you had a fixed number of them and you had to make sure that you didn't collide with anyone else. And so here's the enumeration of that. You had the higher bandwidth voice channels and a low bandwidth control channel that would be used to communicate with the relevant parties to make sure that all worked. This is a super simplified view. The diagrams I was able to find had so much technical complexity that it was like not even useful for a thing. So that's why you get my rendition here. The cellular channels use that, or cell networks use that control channel to do a handful of things. Authentication is one of them. We do that with SIMs today, right, where you're authenticating to the cell phone network so that they'll pass traffic for you. They also handle cell routing, or call routing rather, so that it knows which tower you're on and it can route the phone call to the appropriate place. Call setup and teardown. And an interesting one here is actually SMS. SMS was created and slid into existing technologies almost as an afterthought, which is pretty neat. Here's some actually interesting reading if you're interested. This is signaling system number 7 is the link here you can see in the lower left of my share on Wikipedia. And signaling system number 7 was the first telephony signaling system to handle the signaling out of band, meaning it didn't use the regular phone call piece of the channel to make it work, but rather it had an out-of-band component that allowed it for much more efficient use. And then, of course, SMS describes how it actually showed up. Interestingly enough, 128 characters was originally the limit of an SMS because that's what they could fit into the existing signaling protocol without adjustment. It was 128 bytes. They later stretched that by using 7-bit characters rather than 8-bit characters to get 160 characters into a text message using the existing stuff. So that's kind of a cool historical aside about how this works. But so DIDComm provides, as a comparison to Cell Network, it provides mutual authentication. Both parties know who each other are. It provides message routing, which is super useful when you have an agent that is on a mobile device or another firewall constrained scenario. And it also provides a framework for protocols for things to be built on top of. There's some bonus features that DIDComm provides as a comparison here. It is decentralized as opposed to the cell phone network, which is very not. It is, you could argue that point a little bit, but I think DIDComm still comes out on top. Provides secure communication, privacy, and some auto config and feature discovery stuff baked into the protocol, which allows for things to be built on it as a foundation. So let's get visual for a second. This is how the diagram that we frequently use for DIDComm. You have Alice on the left, Bob on the right, and they each have a DID and a DID document. They use DIDComm. They use DIDComm protocols supported by DIDComm to communicate and do interesting things and talk back and forth. DIDComm itself has some very specific properties in the sense that it is message-based, which has some really nice attributes to it, but also doesn't do things like low latency or high bandwidth. That's not what DIDComm was designed for. And so it has some specific limitations in that manner. We'll talk about how that's not a problem in just a second. So I'm arguing and positing here that DIDComm is the control channel of decentralized identity. It is that it's the means by which parties interact and bootstrap things into existence and handle authentication and trust as part of what happens there. It's worth noting that interesting stuff can happen within the control channel, and this is the case with SMS. The SMS itself, the text messages traveled directly within the control channel and didn't need anything else to occur in order for that text message to actually transfer. That's really useful. Now, ignore history for a minute. SMS sort of came later. In our case, it's not because we have the benefit of hindsight. But we have, so interesting stuff can happen directly. DIDComm already has interesting stuff happening directly. Credential Exchange is an obvious example of this, where you can ask for, issue or ask for, present credentials all within DIDComm protocols, and that works quite well. Interesting stuff, and I think we're familiar with that concept. That's, most of us that have had interactions with that are familiar with doing that stuff directly within DIDComm protocols. Interesting stuff can also happen bootstrapped from the control channel or from the DIDComm connection that provides it really useful abilities. And when you do that, some useful stuff occurs as part of that bootstrapping. So here, back to my amazing visuals here for a minute. You can have a DIDComm protocol that causes for interesting stuff to happen outside of DIDComm itself. This is fairly obvious in the sense that if you had a DIDComm protocol, for example, that facilitated maybe ordering or payment at a restaurant, obviously the food is not delivered over DIDComm. That's kind of a silly example, but I'm making a point here, is that often the interactions that we have sort of other band interactions or side effects that happen in a super useful way. We don't really want our hamburger to be digitized and delivered in a normal fashion that we, over a payment rails, for example, even though we might have paid for it with a credit card. And so multi-channel or multi-band interactions happen all the time in our life, and we should apply the same concept to DIDComm and the interesting stuff that it provides. It's worth noting that because of the relationship of the interesting stuff being bootstrapped from DIDComm protocols, any of the trust and the interactions and the circumstances that exist within the DIDComm relationship can provide that or lend that to the interesting stuff that happens on top. And that means that, for example, if Alice and Bob have exchanged credentials and they trust they have built trust in that relationship with each other, that when they begin the interesting stuff, they're not beginning the interesting stuff in a vacuum, but they're beginning the interesting stuff based on the trust and the sort of the history and the relationship that they already have. And that's really important because it gains and it allows you to transfer the trust from the DIDComm relationship that you had into whatever interesting stuff that you're causing to happen in some other channel. So I think I just said this, but you can transfer that trust becomes transitive between the relationship that you have and the interesting stuff that you do when it happens there. So what is this interesting stuff that I'm talking about? What do I really mean interesting stuff happening outside of that? Payment and money transfer. I have a handful of examples here that I'll talk through, and I'm ending, of course, with the one that HearRo does really well, which is why I'm grateful they're here. Payment and money transfer is an interesting one. You can coordinate payment over a DIDComm protocol relatively easy, but allow for the actual payment transfer to happen on whatever payment rails already exist. For example, you can provide a credit card number information to a merchant over DIDComm, but they're going to run the credit card on their existing payment rails network, and that makes sense. But they have a pretty high degree of trust about the person that they obtained those credit card details from, which means that that leads to low risk scenarios and everything else in a really useful way. You can coordinate all sorts of things, not just the details of a single payment method, but maybe which payment method you're going to use. You walk up to a taco truck, you engage in a protocol automatically. You can discover that they'll take cash, a credit card, or maybe a Bitcoin transfer. And you can decide, or your software can help you pick among those, obviously the ones that you both support, and then can facilitate the transfer of money in a really useful way. So again, the money transfer is happening outside of DIDComm, but it's coordinated from within a DIDComm connection. Another one is shipping. This would allow us to reimagine shipping in a really useful way. I could go to a shipping company and say, I would like, here's my shipping details, and here's where the information is being sent. Please provide me an anonymous token of shipping that I can then give to my merchant, and then I can provide that to them. They can still get the shipping quotes as everything is necessary, and even send the item as a package. But it's not until it actually gets to the shipping company, is it paired with the actual destination address in a way that's really meaningful. And so now I have privacy and being able to receive someone and don't inadvertently have to reveal my shipping address to everyone that I want to buy something from. There's other things, of course, you could do really well there. The efficient recipient communication, right? The shipping company now has a relationship with me directly, which means that if I happen to be out of town for the day and I'd like them to hold it, or there's some sort of problem, a truck got in an accident and it's going to be delayed, there's really easy communication that they can have with me as the recipient of that. And so this is something that I would love to happen. I know there's some things kind of happening here, but I think there's better potential using the power of DIDComm and decentralized identity to make that happen. Spatial web and the metaverse have been talked about a lot of things. One of them is communication or payment or things like this. If we have lots of different metaverse worlds, then having to sort of re-sign in or re-authenticate or reset up payment for all of those could be really tedious. And this would allow that to work in a much more streamlined way, as well as portable reputation. If I have gained a reputation in some metaverse world, making that portable to another one would be really valuable for all the participants involved. Not just people, of course, but the platforms that are trying to manage reputation and figure out how to handle interactions and permissions. The web is kind of an obvious one. I've placed it later here in the stack because I didn't want people to get sidetracked and misunderstand what I meant here. One of the things that can happen here, of course, it affects login. Logins, and we all hate passwords, and there's various attempts to solve passwords. Apple's recently made news with their adoption of FIDO, which is good and fantastic, but it only starts to get to the potential of what we can really do here. Logging in should really be a side effect of the digital relationship that we already have with an organization, rather than the primary activity that we take there. So if we have a relationship through decentralized identity using DIDs and DIDComm, then logging in is a side effect of that relationship that we already have, to the effect of greater security, but also really useful interactions, offline confirmations of things, or user-side storage of data from the website would be really useful, and authorization for future tasks. It's possible that I log into my bank, but if I transfer a large amount of money through a web interface, they might want to reconfirm with me that that is in fact what I want to do. DIDComm is a great channel to do stuff like that on. And so there's obviously really cool applications with the web here. Here's the really interesting one. What could we do with voice or video communication? DIDComm's a super bad, directly, it's a super bad application of this. The latency is too high. The message-oriented nature makes it, would provide way too much overhead for such interaction. But what could we actually provide by bootstrapping into this? One of the things that I really like is phishing prevention. If your communication channel is responsible for its own authentication, then that's often a very difficult thing to do with a good user experience, which means we leave ourselves open for things like phishing attacks, where people are impersonating someone else and trying to get you to spill information that you ought not. And there's some really cool things that can come from this. But I don't need to talk about this one because we have experts here in the room. Let's hear from HearRo about what they're doing to apply this. The reason I'm picking on HearRo a little bit here is because I talked about some of these concepts at IAW earlier this year, and Seth was in the audience and was talking excitedly about the way they've already been applying these concepts. Now, I didn't invent these concepts; they're not new, but I've been trying to evangelize them, and it was so wonderful to hear from them about what they've been doing. And so we invited them to talk a little bit about how they've used this concept in their work. So why don't I pass this to probably maybe to Vic to get started, and then
Sure.
to talk about what you guys do to give some context, and then we can and then after some examples and some demo stuff, we can get into some conversation.
Yeah, I mean, that's a great introduction to kind of the potential of DIDComm and in communications. And just to give you a sense of, why we developed HearRo, goes back to, my background was in telecommunications and working for a software vendor building contact center software. And I would go into all these companies and program and design a contact center solution. And I just started noticing that all the companies I was working with were pretty much solving the same set of problems. And one of the main ones was identity. Almost every phone system you call in, they have some mechanism to figure out who you are, to basically do some sort of identity proofing. And if they don't do that, they're basically just taking an educated guess based on your caller ID. It's not really what you would call, authentication. It's more like, well, it's too much trouble to authenticate you, so we're just going to guess. And then once they get you on the phone, then they take you through those, lovely questions that we all like to, what's your mother's maiden name? What's the model of the car you first bought, and stuff, right? And I just as somebody who likes to solve problems, I was like, I'm so sick of this problem. I'm going to figure out how to solve this problem. Little did I know that it was like this huge rabbit hole. And that kind of led me to, trying to figure out, well, what kind of identity solution would I use? And I sort of had this model in my mind of, I want to build Uber for contact centers. Like, I want to have the experience when to get an Uber, they know who you are. And, the key thing here, and this is sort of something we strive for in every contact center, is the main goal is to reduce effort. So anything you can do to reduce effort not only makes the customer much happier, but it saves you real dollars, because in a large contact center, every second really that you spend identifying a caller is basically money you're throwing away, and serious money. Like, we're used to not having to, pay for our phone calls, but companies still pay for their phone calls to come into their, as a business, you have to pay by the minute to have these people on the line. And then you're also paying for the agents, and which is, a huge cost, and agent burnout and all these things that happen. So anyway, looking for the solution led me to SSI, and ultimately to understanding about DIDComm. And I had this aha moment where I realized that SSI wasn't just the authentication layer that I was looking for. It actually was the communication network. Because when you break down what is a communications network, it's basically, I define one endpoint over here and I define the other endpoint over here, and then we send data back and forth, right? Now, on a regular communications network, the endpoint is typically a device. It's, actually a phone. In the original one, it was like, okay, the phone number represents your phone. It doesn't represent you. But the amazing thing about DIDComm is the endpoint basically is you. And so using that, using DIDComm in order to create these, basically unique channels between you and everybody else that you communicate with, and where I don't have to give out a number, like a shared secret, over and over again, which is what causes phishing problems and security problems and all of that. It's basically, if I connect to you, Sam, we have a number. Basically, I have a number that represents your endpoint, and you have a number that represents my endpoint. And then that's it. We don't need somebody in between. We don't need anything else. So that kind of opened up this, amazing sort of possibility, is that not only can we authenticate you, we can actually create a new communications network. Now, like you said, DIDComm doesn't provide audio video channel. It's that interesting thing that happens on top. And, there's this technology, hopefully people are aware of Webrtc. It was developed by Google. I don't know, God, it was back in the early 2000s. And it was supposed to be this amazing thing that was going to transform communications. And every company was going to adopt it, and yet every company didn't, or hasn't. And the question is, well, why haven't they done that? And I feel like part of the big issue there is that it didn't come with any kind of authentication. You can basically, as a company, you can open up Webrtc, you can provide it, but that doesn't solve the who is calling question. So I sort of, realized, well, what we need is a way to deliver Webrtc along with this SSI DIDComm sort of network. And that gives us the basis for a new communications network with some very interesting properties, one of which is those connections basically are, in a sense, permanent. Like, I'm not reestablishing the connection every time. With SSI, with DIDComm, unless there's some reason why I want to break the connection, you can really imagine these connections could potentially be lifetime connections. So, I don't want to go too deep into the details. I know that what we wanted to kind of give people was a flavor of it. And so that's, Seth has kind of put together a little bit more on the, just give you the technical sort of structure of it. And then maybe we'll do a little bit of a demo of it. And then I guess we could do some questions and answers or have more of a dialogue about it. But that's the basic thing. And it's actually quite simple. And it's amazing to me how simple it is. And it's one of the challenges of it is like getting people to shift their mindset that they don't have to have a third party in there to create a communications network. You know, we always think of the phone company. There needs to be a phone company for the phone network. But really for DIDComm, there doesn't need to be a phone company. So there's other services that are needed, but not the phone company, not the central office. So yeah, so Seth, if you're ready, do you want to kind of run
sure,
through what you prepared?
Yeah, let me share my screen here. Yeah, I'll kind of just go through, like Vic said, just kind of a high level of more of a technical side of how we're using DIDComm at HearRo. So everything Sam had said about, you know, using it as, you know, kind of the messaging and the message service for doing other interesting things is definitely what we're doing at HearRo. And I almost called this sort of DIDComm all the things, because that's kind of what we do. So as Vic alluded to, it's really identity-based communications is what HearRo strives for. So rather than, you know, the typical telephone network where kind of identity was baked on after the fact, or inserted after the fact when you know, the internet was a friendlier place. You could actually believe people when they said, "Hey, this is my caller ID." You know, HearRo starts with identity first, and what that means is that identity pervades our entire system, right? We start with understanding who's communicating with whom. But then we also wanted the privacy preserving aspects of that, right? Just because, you know, identity is baked into it doesn't mean that you want to have correlation between who's talking with whom, and obviously you need sort of the end-to-end encryption and all those types of things. And so given those first two, I mean, it's almost inevitable that, you know, DIDComm is throughout the system, right? Both internal and external. And the interesting thing here is obviously a lot of times when people think of DIDComm, they think of like, oh, it's a message, you have an endpoint or an agent, and then that's where you terminate it, and then you take it into your system and you do interesting things from there. DIDComm, we bring it right in. It goes straight through our API into our internal systems, and then all of our internal systems are actually DIDComm based. They communicate DIDComm back and forth to each other. So that kind of, what does that look like? We have a really minimal API surface area. So, you know, there's the interesting things of like, oh, create an account, some of those types of things, but the main workhorse is the endpoint where the external sort of wallet is sending DIDComm messages into the API, and then those get brought right into the internal network, and the services inside passing around. It's message based, which is obvious because it's DIDComm. But the interesting thing about that is, you know, it works very well in sort of a distributed streaming type of architecture. So event sourcing, which is very much what we're based on. So, you know, DIDComm, as we were designing the system and building it out, lends itself very, very well to that type of an architecture. And then there are things, we have lots of thin agents, and I wanted to emphasize thin because depending on where you're coming from, you know, especially if you're familiar with like Octopi or Aries Framework Go, some of these other agents out there, you can think thousands of lines of code, very fat, they do everything. We didn't want that. We don't need a lot of the functionality. You know, we need functionality for handling DIDComm, for doing some of the verification of credentialing and those types of things, but we didn't need everything else. And so actually, when we started down this road, Aries Framework Go was still very young, and you know, so we couldn't kind of use off the shelf agents. So we ended up developing sort of implementing the protocols and thin agents. When I say lots of thin agents, every single microservice, you know, our 8-10 plus microservices internally have agents attached to them, essentially because their predominant communication back and forth is DIDComm. So what are the benefits? You know, again, minimal API surface area and reusable code. Like, we do not have a gigantic Swagger spec or GraphQL schema, because we have obviously a very minimal ingress, but also our microservices. There's not a huge, like, you know, we use gRPC, but it's really one endpoint. Send a DIDComm message, and we can reuse that code because they all use the same basis for getting the message. What they do with it, the business logic, the process goes, is obviously different, but the actual communications is very you know, reusable. Security in depth. You know, if you're using something like Kubernetes or some other kind of container management, you think of, well, I need a service mesh, Istio, which are great for a lot of different reasons. But with DIDComm, you get security in depth kind of out of the box, right? I mean, especially if it's a message-based event sourcing type of a system, the message is encrypted to the recipient, and they, if you can decode it, read it, you can decrypt it, read it, you understand there's context around who sent it and who's receiving it, and it kind of bootstraps a lot of context into your business logic. And if somebody intercepts one, it's not not readable. And then it also is easily wrapping other services, and I think that's the sort of material point here with Webrtc, but also chat, file upload. I mean, we do lots of things, and we wrap all of those in DIDComm. DIDComm is message based, and it goes back to what Sam is saying, the interesting things on top of it. Quite honestly, DIDComm is a fairly efficient messaging service, but you can't obviously do real-time streaming, although I have tried with it. But you can do a lot of really interesting things on top of it. And that's, since we bring DIDComm straight in and throughout the system, it's very easy to do those other interesting things because everything's already familiar with it. So for the RTC, just kind of a visual, all the arrows, that's all DIDComm, right? So hits the API, it's a DIDComm message, goes to kind of a user agent. DIDComm message understands that agent's acting on potentially on behalf of the Edge wallet. It talks to the conversation over DIDComm, which has context about what conversation is being created and what context, who's a part of it, and security there, because everything is, again, messages, DIDComm messages. The RTC service is, if you're familiar with RTC, and the next slide has, I think, kind of a picture of some of the protocol, but the control channel is not defined in RTC. The messages are, but how you send those messages for negotiating your real-time communication is not defined. So we wrap those up in DIDComm, throw them on a message bus, and if you're negotiating a real-time communication with someone, you can pull those messages off the message bus. Obviously, they're DIDComm, so they're encrypted just to you. The recipient's the only one that can read it. And then you're able to negotiate the actual real-time communication from that. So that's kind of a high level of how it looks and how it kind of works. An example, that's pretty small, I can make that bigger. An example of, can I make that bigger? I can't make that bigger. An example of how that kind of looks is there's the RTC trickle message. So this is just an example of it. It's a trickle message, comes across the message bus. It's saying, hey, it's going to this DID peer. So we have identity baked into it. It's for a particular conversation, and it's saying, hey, here's a candidate that we can potentially talk in real time over. If you want to negotiate this particular IP address and port to actually send our audio and video over, then talk to me here. But as we're negotiating that, I understand who I'm talking to because I have a DID peer connection with them. I'm actually communicating with them over DIDComm. And again, that just goes back to the control messages are defined. This is a signal type of a RTC trickle, but it's not the transfer. It's not. And so we just stream those out. And again, you can do lots of really interesting things when you have sort of an event sourcing message streaming architecture, and DIDComm lends itself very, 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 very well to that. So quick demo here to kind of just show it in action, I guess. We'll just do it really quickly. Just create an account here for me, and I'll do a demo account over here. Type user. So we're both inside the HearRo network right now. I'm going to go ahead and invite my other user there that I just created. I can see now in my connections, I've got an invite from the demo user. I accept it. This is all very sort of standard DID peer connection, communicating back and forth. But the interesting thing now is I can start a chat. And so I'm actually here in the chat. And if I go back up here, I can see a conversation or a chat where I'm chatting back and forth. And this was all negotiated using DIDComm, right? So we use DIDComm obviously for Webrtc, which I'll show in a minute, but we use it for everything. And that's part of what is so powerful about it is we have identity baked into everything that we're doing. Two members, I can type messages. I can say hi back. Again, this is all messages that are just streaming out. They're DIDComm messages that are streaming out over the event bus, and then the individual clients are picking them up. You can do file sharing. This is another fun thing that you can do on top of DIDComm. It's one of those interesting things. Is, you know, we can upload files, and I have identity baked into who actually uploaded it, because again, it's all DIDComm based, and the identity is there. And then obviously the fun thing is the joining the HearRo call, where we actually negotiate the real-time communications, and the audio and video, going over the control channel was used to negotiate the actual audio video connection, and then the audio video connections are direct. So, but yeah, that's all of this is all DIDComm. I mean, from the browser into the API, and then obviously inside. There's a lot of complexity. Not a lot, but there is a certain amount of complexity both with RTC, but then also in DIDComm. So, you know, we wrap everything in an SDK, and this is built with the SDK so that you don't have to navigate those complexities, but you still get all the benefits from it. So, yeah. So with that, I'll leave it there and hand it back off to Vic or Sam or whomever.
Well, you know, one of the things that strikes me looking at your diagram is, like, if you think about that, not just, okay, here's how HearRo works, but you can think about, you know, comparing that to what we would consider a traditional communications protocol or communications network, right? If you could imagine the phone system operating like that, right? And so we're introducing this, you know, really some powerful kind of concepts of these permanent connections that can then create persistent conversations that then can have many sessions attached to them. And it's sort of the reverse of the way a lot of communications works now. It's like, you know, every time you make a phone call, in a sense, you're going back the other way, and you're trying to reestablish the original, like maybe you're calling a company back again and say, well, you know, I called you yesterday. Do you have a record of it? It's like, oh, well, darn, you don't. Okay, well, here's what it said. And then, oh, and then, you know, you got to authenticate yourself back again, right? Versus, you know, this concept of like, you're basically, as a company, if you can imagine, you can wrap your head around, you're going to have a permanent endpoint for every customer that's independent of the channel that you're actually using, you know, audio, video, file sharing, whatever. It's like you have your very own endpoint to all your customers. And you know, it takes a little bit to kind of realize, well, what does that mean as a business, that I don't have to basically do that every time I want to talk to one of my, you know, and then it goes two ways, right? There's you know, a lot of times, you know, you call into your bank and your bank asks you to do all this stuff to authenticate. And then an interesting question is like, well, how do I know you're my bank, right? I mean, you've just authenticated me. You've made me jump through a bunch of hoops. Now, you know, what are your bona fides over there? And that, you know, we're so steeped in it, we don't understand how much effort it is. We don't understand the amount of waste and inefficiency that the lack of this control channel and the identity ends up creating. So
Vic, you're pointing out this inverse thing, and it's not just true in telephony, it's true on the internet, right?
Yeah.
In fact, because HTTP, for example, was stateless sort of originally, we invented the cookie in order to be able to keep track of one web request to another web request, and that way you could sort of correlate things. And that was really the beginning of the transition from the web as simply a way to publish something to the web as a way to interact with something, because you had to be able to sort of manage things across separate requests. And yet so telephony's got this problem. You know, we constantly have that. And what you're talking about is, rather than establishing the session and then figuring out your identity, if you bootstrap the sessions from your identity, that becomes a non-issue. You get all the security benefits, but you also avoid all of the hassle of trying to prove that you're the same person that you were that walked in last time, in order to sort of enable a relationship and an interaction there. In a lot of ways, it's the same with like a restaurant. Unless I'm a super frequent customer in a restaurant that's small enough that they can get to know customers, then they're likely not going to know me from one to the other. And so the net result is sort of a cold relationship there, where there's not a lot of historical context or other things happening. They don't know what I ordered last time. They don't know what happened or what the interaction was like or any of that. And there's times where it's nice to be anonymous, but there's a lot of times where if we had the privacy respecting ability to have a long-term durable relationship, then that's a better circumstance for all of us, right? It's interesting that reproving who you were is where all the fraud creeps in. Because if someone else can do the same thing and solve the who you are question, but errantly, of course, because they're not me, then that's where this whole thing starts from. And so the ability to sort of flip this over would be really nice. I've observed with a couple of different technologies that it would be nice if we had a time machine and we could actually go back and take some of the newer developed technologies and install them earlier in the history of all of this, so that we could have spent more time sort of building on those technologies rather than trying to sort of solve the problem in less efficient and less effective ways, right?
Well, and if you go back to what I was originally saying about like all of these companies that were developing call centers, that I helped them develop call centers, they're spending an incredible amount of money and time all solving the same problem, and which is something we're doing all over the place. It's like every company has to solve this problem, these sets of problems, because they're not baked into the protocol. And if they're baked into the protocol, then, that's my understanding of what software is supposed to do. It's supposed to take stuff that's complicated and that we don't want to have to do and make it easier. And it often seems like it goes the other way. It's like we're having to put kludge on top of kludge. And when you look at the communications software vendors that are out there now, whether it's Genesis or Five9s or all of these places, when I still do work on those kind of systems, and it's just like, wow, we are really working hard here for something that should be baked in.
So it's interesting that you mentioned everyone, we're still solving this problem. So the Internet Identity Workshop is frequent in the identity space. It's a great conference that's held twice a year. And if you hear Phil Winley, one of the conference organizers, talk about the origin of IW, he was together with some other peers and realized that they were all wanted to build something neat on the internet, but it didn't work very well because they had this identity problem. So they said, well, we should just get together and figure out the identity piece of it, and then we can all go back to building the other interesting things on the internet. Simple. And so they anticipated having one or maybe two of these. This fall will be IW 35. So it's taken more than twice to solve it. But there's some excellent things that have come out of it. A lot of the concepts behind the previous advancement in identity, which was federated identity, happened at IW. A lot of the decentralized identity stuff is happening at IW, and so there's lots of stuff moving forward, lots of conversations about credentials and how to make this stuff work. So this is a bit of a side note, but if you have not been aware of the Internet Identity Workshop, Helen dropped a link. Appreciate that, Helen, in the chat, and that's worth attending. It's a fantastic conference, and a very, very good use of your time and energy if you're at all related in identities as it applies to the internet. Okay, so back off from my squirrel about IW here for a sec. In the process, this may be a better question for Seth, but in the process of building what you've described, you've obviously designed at least several of your own DIDComm protocols, meaning these are not protocols that are documented in the community necessarily, but ones that you created specifically for the purposes that you have, particularly the internal ones. Can you talk about how DIDComm protocol design is similar and how it's different from API design?
Yeah, you hit the nail on the head there as far as we have a lot of protocols that we utilize. you know, even amongst our microservices. I think one of the biggest things is you get so much context when you're sending messages over DIDComm, right? So, you know, if you think of the typical API ingress, you have a JOT or, you know, JWT, some sort of, you know, identifying thing that you send in, and then depending on how you're implementing your API, you do all sorts of, you know, message or, you know, maybe payload hashing and signatures, and you have all these things to try and say, okay, well, my payload to the API hasn't changed, you know, in flight. It is actually from who I said it was. You know, this JOT has all of this authentication data baked in. It's all just kind of tacked on to, you know, the payload that you're sending into the API. DIDComm protocols are completely different because, again, if I am a service and I receive a message and I can decrypt it and read it, I have all sorts of context around who sent it, who it's supposed to be for, and, you know, all of that sort of identity authentication encryption. It hasn't been changed in flight. All of that's baked in, and so I really, it's not complicated, but it's a mind shift when you start thinking that way, especially when you're designing sort of internal services. But that simplified API and code reuse, I mean, once you get there, it really does simplify things, because you know, you can write code that decodes the messages and handles all of the DIDComm type things, and then your business logic can just live and handle the business logic, and you don't have to worry about a lot of the the identity and authentication and payload integrity and a lot of those other types of things. You know, it's definitely thinking a little bit different than you would with a typical API, but you know, protocol design, it's just message-based protocol design. So it's not, again, I think it's not anything that hasn't been done or hasn't been talked about or hasn't been discussed before. DIDComm is just a very, very convenient tool to do it with.
So the batteries included nature, meaning you get message integrity, you get privacy, you get the authenticated
100%.
encryption, means that by the time you're looking at the message, you know who sent it. A lot of that stuff just kind of comes for free. I mean,
Yes.
by free, I mean it's already happened because of the structure you've built on. And then you can really, if you're designing a new protocol, it isn't really a scary thing, because all you're thinking about is, what do I want to say to the other party, right?
Yeah, absolutely.
The other piece that I think is different is that in APIs, we always have to figure out who's calling who. And often, if you have a mobile component, they can't ever be called. So they have to like poll or, you know, other mechanisms to get data back from an API, for example, if they're there. It DIDComm's not that way. There's not even a need to have a balanced pattern of communication. It's not request response all the time. There's some of that, but sometimes you're going to keep sending stuff from one party to another, and that's normal. Or you could have a lot of messages one way and only a few messages the other. And so there's all sorts of things that happen there. But I appreciate you highlighting the batteries included nature of that, because it kind of means you don't have to worry about that anymore in a really convenient way. Yeah.
Oh, 100%. Yeah. And I think it definitely, to sort of the asynchronous nature of it, it definitely, you know, that's part of why I highlighted the sort of the event sourcing, the message bus, the streaming system is very much how we run things in HearRo, and that's DIDComm lends itself to that. Obviously, it's decentralized, it's asynchronous by nature, and so if you're already familiar with distributed systems that use sort of a message streaming and event sourcing type of an architecture, I mean, DIDComm is perfect for that. And again, because the batteries are included, you don't have to worry about a lot of the problems or identity problems that normally come with that type of a system. So,
and there's an interesting thing when you think in terms of, like, what does it mean back to calling into a company, and how would it be? It's like, basically we eliminate the need to put somebody on hold. We eliminate transfers, and we eliminate starting over, right? Because of the nature of what the protocol gives us. It's like, if I need somebody to contact me, I'm basically can asynchronously send a message saying, hey, I need somebody to contact me. I don't need to wait. You know, I don't need to set up a callback, right? Callback is included, right? And so really, it's just a matter of, you know, that I can see that I've sent them a message and the ball's in their court, and then I can go about whatever I need to do. And because they have a way to get a hold of me, problem with callbacks is that people don't answer their friggin' phones, right? Because a lot of times you get have that where they call on a number and you don't see the caller ID, and I'm not answering that call. That's going to be a telemarketer. So, I don't trust that call. And so I miss this important call from, my doctor or my bank, and all that stuff goes away because you have that ability. And then basically you have this constant, you have this permanent connection, and then you have a persistent conversation, which then we would go, okay, actually it would be more useful for us to have real-time audio right now, well, AKA a call. So, I just say, let's have a call. But then at the same time, because the channel doesn't get decided until the very last minute, I can switch channels at will, right? If suddenly I need to text, I can send a text message. If I need to go to video, I can go to video. I mean, so I don't know, it's such a better way of doing this kind of interaction. And then the other point I think is interesting is, where you talk about the connections themselves have a lot of information in them. The context is included. And we haven't really talked, we really are talking kind of in form of like, hey, Sam, I just called you, or Sam, you have a company, Indicio, and I call Indicio, or whatever. But it really is identity, not just for people, but for organizations and for things. And when you put things in the middle, then suddenly you have this incredible layer of information, because now I can basically call in the context of the thing that I have, which then gives you like, if I'm calling this company about a thing, they can look at and say, oh, he's calling about this thing, so it should go to this person, right? I shouldn't have to answer a bunch of menu and press a bunch of buttons. It's like, where the hell is the department that goes for the, the widget that it should just go.
Yes, totally. So we're running short on time here. I very much appreciate the context and the color added to this conversation by Vic and Seth from HearRo. Really quickly before we ended, there was Robert asked a question in the chat. How does DIDComm intersect with passkeys, since identity for most people will likely start with passkeys managed by a vendor's keychain? We could have a really long conversation about this. The short answer is that if you have identifiers that already exist in the system, there's no problem with either passing those or proving those over a DIDComm connection in order to bind any previous identifiers that people have with the DIDComm connection. A simple example there is an email address. I can use a service to prove that I control an email address, and then I can provide that as a credential very efficiently across the DIDComm connection. And now you have a sort of a trusted link between the DIDComm connection that we have and an email address that you might recognize from some other context. And that same thing happens with passkeys. You can do, there's all sorts of ways to make this happen. If this really does change the world, as we are definitely planning and hoping for, then in the future, that I don't think the origin of identity will be passkeys necessarily, but it will be actually having a trusted relationship that then you elevate the trust in with other things, with credentials, with other sorts of things that happen. And so I apologize that that was a short answer, given our time. But if you want to reach out to me directly, I'm sam@indicio.tech is my email address. I'm Telegram Sam on all the socials. And if you pop up in any of the relevant chat channels for DIDComm or Hyperledger areas, then I'll be there, and we can get a little bit more into detail there. I'm super grateful to Vic and Seth for coming. I had to, I invited them and explained why I was talking about this and what the point was and why they were perfect, compatriots here in the mission to sort of help people understand the value here. And so I'm very grateful for their color and participation. And thanks a bunch. Maya, back to you.
Thank you, Vic, Seth, Sam.
Thanks for having us.
It was an amazing discussion. Time goes by so fast. Quickly, next month for Dry, we're gonna have the our meetup on July 19th, Tuesday at same time. We are still in discussion for the topic. You're welcome to send me the suggested topic for the future at indicio.tech. Thank you very much for coming again, and I hope to see you next month.
Thanks, Maya.
Thanks, folks.
Thanks, everybody.
Thanks, Vic. Thanks, Sam.